Hey everybody, welcome to my movie on how to find local noon on your shadow plots, even if you weren't out making a point at local noon. And this works because of our wonderful symmetry we have. We know that the ecliptic of the sun has this nice parabola that it makes, and that local noon is this highest part of the sun with the shortest shadow. And the nifty part is, because there's so much symmetry and consistency in our shadow plots and in our ecliptic, it makes finding this point kind of easy. And so I'm going to take this shadow plot right here, which I really just made up, but I made it up. It's taken basically the same time of year as the one that you currently have. And you'll notice also that I did more points in the evening than I did in the morning. And remember, one of the things about a shadow plot is we can't start them like an ecliptic right at sunup and sundown, because the shadow point won't hit the earth. So we never can do this real easy, just fold it right down the middle and get the line of symmetry. So I'm going to show you another way to do that. Now, the first thing, which you have already done on your current shadow plot, is to go ahead and connect your points so that we can see the trend of the points. And I could even, and it actually helps for checking this, I could even just keep extending that on this side of the paper, even though I don't have any points in here. You see that the line pretty much stays the same. Now, you can also probably tell that local noon probably occurred somewhere in here, because that's where our shadow point line is the closest to our gnomon, meaning the shortest shadow. But we want to find this with a greater degree of exactitude. So one way to do it is, or the way to do it is this, and that is, we're now going to use our ruler and actually make some measurements on here to find it. And you kind of have your choice of measurement. For this line, because of its distance, I am just going to make it at 3 centimeters away from the gnomon. And you'll see I'm at the gnomon tip right here. 3 centimeters right there. I'm going to make a little line right at the 3 centimeter mark. And I could have chosen 4 or 5 as well. It wouldn't make any difference depending on what the shadow plot looks like, because they will change with the seasons, which we'll find out pretty soon. But depending on where it is, you just choose the number. The key is, if I choose 3 here, I've also got to do 3 over here. So now I'm going to put the gnomon right on 3, and I'm going to move this to where I'm coming right out on the line, and I'm going to come out here and I'm going to make another mark. So what I've got is, I've got a mark here that is 3 centimeters from here, and a mark here that's 3 centimeters. And again, I could have done 4 and 4, 5 and 5, 6 and 6. It really doesn't make any difference. But now that I found this point and this point, I can measure the distance between them, which on this one comes out to about 4.6 centimeters between those two. And then I'm going to take this 4.6 and I'll cut that in half, which would be 2.3. 2.3 is right about there. This point that I just drew is right halfway between these 2 points, or as close as I can make them. Now all I got to do is go from the gnomon through that point, and I just found the line of symmetry on my shadow plot that coincides with the line of symmetry in my ecliptic. And the final thing is, there's a great way to check and see if you did this right. And that is, you can take your paper and you can fold it right along that line of symmetry, and you'll notice that the shadow plot line does something consistent, and that's that when we fold it, the lines fall right on top of each other, just like these lines would fall on top of each other if we folded this down. And so that is how we find local noon on any shadow plot. Now, we don't know the exact time, but we do know the exact place. This right here marks the shortest shadow of the day, or the highest altitude, the altitude that the sun reached. Okay? Now I want you to do this on your shadow plot that you have, because you're going to be asked to find the altitude of that point. Thanks for watching.